Hey everyone, I want to walk through a product engineering prototype I built called the Behavior Insight Engine. The core engineering challenge here was taking raw, noisy financial transaction strings and orchestrating a pipeline that transforms them into structured consumer intelligence. Before we jump into the UI, I want to quickly highlight the architecture. The goal wasn't just to call an LLM, it was to build a reliable data pipeline. We parse CS with client side, run them through a concurrent batch processor, enrich them via Gemini 2.5, enforce the schema using Zod, and then split the clean data into two streams, one for deterministic analytics and one for a secondary AI behavioral synthesis pass. Let's look at how it runs. Here is the ingestion zone. For this demo, I am using a dataset of about 45 intentionally messy transactions. We have processor prefixes like SQ and TST, alphanumeric IDs, store numbers, and weird routine tags. I am going to drop this in. Instantly, our client-side PapaParse layer sanitizes it, hydrates the Zustand store, and we enter the pipeline. Right now we are in pass 1, enrichment. Because processing 45 rows sequentially is too slow and doing it in one massive prompt causes hallucinations, we are using a sliding window promise pool to orchestrate concurrent batches. You can see the telemetry in the top right tracking our velocity. As each chunk resolves, we are progressively hydrating the Zustand store. What's crucial here is that we are enforcing structured outputs via Gemini's schema definition and then revalidating it through Zod on our API route. We are treating the LLM strictly as a normalization engine, forcing it to strip prefixes, categorize the spend, and assign a confidence score. For internal tooling, observability is non-negotiable. This can't be a black box. If I click on this Costco gas transaction, we slide out the telemetry drawer. We can inspect the exact raw string, our batch latency, and the deterministic JSON output from the model. Notice the model's reasoning. It knew to drop the store number and categorize it as fuel, not generic groceries. But AI isn't perfect, so we have built in graceful degradation. Look at this POSTI. The model couldn't figure it out, so it returned a low confidence score, which our UI automatically flags for human review. Furthermore, if a row outright fails, like this Venmo transaction, which likely hit an API safety filter, or Zod boundary catches it, instead of crashing the whole pipeline, it degrades that single row to an error state, allowing the rest of the batch to finish successfully. Once pass 1 finishes, we take all the successfully enriched rows and trigger pass 2, behavioral synthesis. This is where we look at the data holistically. We prompt the model very strictly to avoid psychoanalysis and focus only on observable platform behaviors. Based on this dataset, it generated persona tags like convenience seeker and subscription heavy. More importantly, down in the habits section, it flagged a specific anomaly. It detected buy now, pay later velocity because we had multiple Klarna and Afterpay transactions. Identifying this kind of risk or velocity markers is the real value of the synthesis layer. You will notice we also have standard charts here for top categories and recurring spend. I want to highlight an architectural decision. We explicitly do not use the LLM to generate these metrics. LLMs are terrible at math and aggregation. Instead, these charts are completely deterministic. They are powered by standard programmatic array aggregations running directly against our enriched Zustand store. This creates a hybrid intelligence architecture if the AI synthesis hallucinated or hard math remains perfectly accurate. Finally, dashboard data is ephemeral. To make this actionable, we can export it. I opted not to use heavy PDF rendering library. Instead, we use a dedicated print style sheet component that intercepts the browser spooler, stripping away the dark mode to generate a clean, durable intelligence artifact that includes our telemetry, synthesis, and a high confidence snapshot. Building this was a great exercise in wrestling with AI unreliability. The biggest lesson was learning to treat the LLMs as just another node in a strict software pipeline rather than a magic black box. The dual schema validation between Gemini and Zod was easily the highest ROI decision in the architecture. If I were to scale this further, the next logical step would be moving the concurrent orchestration of the client and into a distributed queue like BullMQ to handle hundreds of thousands of rows. But for an MVP, this architecture proves out the core workflow of transforming noisy data into actual consumer intelligence. Thanks for watching.